Now we are going to solve one numerical problem, means how we find eigenvalues and eigenvector for a given real symmetric matrix. In order to save a time, here we already write a matrix A. Using Jacobi method, find all the eigenvalues and corresponding eigenvectors of the matrix A. And if you closely observe, the matrix A is a what? Matrix A is a real symmetric matrix. So only we able to find out the eigenvalues and eigenvector if matrix A is a real symmetric matrix. So as we know that in a Jacobi method, first of all we choose the what? We choose the largest off diagonal elements from a given matrix A. So we choose largest off diagonal elements in a given matrix A. So here the largest off diagonal elements element is what? Off diagonal elements means off diagonal element is a 2 and position of this one is a A13. So first of all we try to convert the submatrix A1 means in this way means A11 with A13 with the 3, the 2 and A11 with the 1, A31 with the 2 and A33 with the 1. We try to convert this part of a matrix into a diagonal matrix. So how we find a rotation matrix or transformation matrix in order to find out a similar matrix? So A1 equal here 1 2 2 1 means we try to convert this element and this element equal to 0. So for this one we find a theta. Theta is a what? Here we write a theta equal 1 by 2 tan inverse 2 A13 upon A11 minus A13. Numerically largest element is a A13. So here what is the value for this one? Theta equal 1 by 2 tan inverse 2 time of A13 is a what? A13 is a 2. Here A13 is a 2. A13, if here we write the value of A13, if here we write first the value of A13 in this case A13 is equal what? 2, A11 is a 1 and A13 is a 1 here. A13, this one is a 2, this one is a, you may also write this one equivalent to A11, A13, A31, A33. Now what is the theta? Theta become what? Theta become 1 by 2 tan inverse 2 into 2 divided by 0. So this one equal pi by 4. So once we find the value of a theta, then what is the S1? S1 equal what? S1 equal means in place of a, what we write here? In place of a A13, here we write what? Here we write this one equal cos theta minus sin theta, and here we write a sin theta, and this one is a cos theta. So in order to find out a what? In order to find out a S1 means a transformation matrix, here we write in place of A11 cos theta, in place of A12 0, in place of A13 minus sin theta, in place of A21 0, A22 1 and A23 this one is a 0, and here A31 this one is a sin theta, this one is a 0 and this one is a cos theta. And what is the value of a theta here? Theta equal pi by 4. So, this become S1 equal cos pi by 4 0 minus sin pi by 4 pi by 4 0 1 0, and this one is a sin pi by 4 0 cos pi by 4 cos pi by 4. So, if we put the values of pi by 4 cos pi by 4 sin pi by 4, then what is the transformation matrix? Now, transformation matrix become S1 equal, the value of a cos pi by 4 is a 1 by root 2 0 minus 1 by root 2, and here this one is a 0 1 0, this one is a sin theta means 1 upon root 2 sin pi by 4 0 and cos pi by 4 1 by root 2. In order to find out a similar matrix, there is a need of a value of a S inverse. So, what is the S inverse? As we know that there is no need to calculate the value of this one S inverse. You may directly write the value of S inverse, because we know that what is the inverse of this one? Inverse of this one is a what? Inverse of this one is a, you may write like this one, S inverse. Here we write a cos theta 0, and here we write a sin theta 0 1 0, and this one is a minus sin theta 0 and this one is a cos theta. Means in place of a matrix this one, means here this one is a matrix cos theta minus sin theta, and this one is a sin theta and this one is a cos theta. Inverse of this matrix is a what? Cos theta sin theta minus sin theta and cos theta, as we discussed in a previous lecture how we find the inverse of this matrix. So, what is the S inverse? S inverse here become, this become cos theta is a what? Cos pi by 4. So, cos pi by 4 0 sin pi by 4 0 1 0 minus sin pi by 4 1, sorry not a 1 0, and this one is a cos pi by 4 pi by 4. So, what is the value of S inverse? Now, S inverse become what? S inverse become what? This become 1 upon root 2 0 1 upon root 2 0 1, and here 0, this one is a minus 1 upon root 2 0 and 1 upon root 2 1 upon root 2. Now, in order to find out a similar matrix, we find out what? B equal S inverse A S. So, what is the S inverse? Here we write S inverse. S inverse is a 1 upon root 2 0 1 upon root 2 0 1 0 minus 1 upon root 2 0 1 upon root 2. Here we write a matrix A. What is the matrix A? This one is a matrix A, 1 root 2 2 1 1 root 2 2 root 2 2, because this one is a symmetric matrix, and 3 root 2 3 1 root 2. So, 3 1 under root 2 under root 2, and here we write what? Here we write S. What is the S? S is a what? 1 by root 2 0 minus 1 by root 2 0 1 0. and what is the last row? 1 by root 2, 0, 1 by root 2. So, once we verify, we write a correct value or not. 1 by root 2 minus 1 by root 2, 1 by root 2. So, we write a correct value. Then what we will do? We multiply this matrix by this matrix. After multiplication of this matrix, we get a matrix, and again we multiply this matrix by this matrix, then we get a matrix, and already we means after multiplication means we calculate in order to save the time. Already we calculated the multiplication of these three matrices. So, what is the value? This one is a value. This one is a B1. So, if you closely observe here, this one converted this element equal to 0, this element equal to 0, this element equal to 0, means Aik and Aki. What submatrix we consider? We consider this submatrix, this submatrix. So, in this submatrix only diagonal element is not 0, off diagonal element become 0. So, now in a remaining matrix, again in a B1 we choose the largest element, again we choose the numerically largest element, largest of diagonal elements, of diagonal element in B1. B1 is a what? B1 is a this one. Here we denote this one is a B1. B1 equal this one. B1 equal this one. Now, what is the numerically largest of diagonal elements? Here, numerically largest of diagonal element is a 2. This one is a 2. This one is a numerically largest of diagonal elements. So, what is the position of this one? The position of this one is a A12. A12 equal 2. So, here we consider the submatrix what? Here we consider the submatrix A2 like this one, A11, A12, A21, A22, and here we use the transformation here sin theta, sorry, not a sin theta, here we use the cos theta, sin theta minus sin theta, and cos theta. Okay. So, now we find the S2. S2 equal what? In these position only we write this matrix, and all other position means all other off diagonal position we write a 0, and in a diagonal position we write a 1. So, here we write a cos theta minus sin theta, and off diagonal elements become 0, and this one is a sin theta, cos theta, off diagonal element become 0, and all other off diagonal element become 0, but diagonal element become 1. This one is a S2. Now, what is the value of a theta? Now, value of a theta is a 1 by 2 tan inverse 2 A12 upon A11 minus A22. Now, what is the A12? Now, here A12 we compare here, A12 is a what? In this matrix B1. In a matrix B1, in B1, what is the A12? A12 is a 2, A11 is a 3, and A22 with a 3. So, what is the value of a theta? Now, theta become 1 by 2 tan inverse infinite, and this become pi by 4. Theta become pi by 4. So, here what is the value of S2? Now, S2 become what? S2 become, here become cos pi by 4 minus sin pi by 4, 0 sin pi by 4, and here cos pi by 4, 0 0 0 1, 0 0 1. So, what is the value of this one? Value of this one is, what is the value of a cos pi by 4? 1 upon root 2 minus sin pi by 4 minus 1 upon root 2, 0, and this one is a 1 upon root 2, this one is a 1 upon root 2, this one is a 0, and last row is a 0 0 1. Now, how we find the S2 inverse? S2 inverse become what? We write the inverse of this matrix, this submatrix. So, here this one is a way, means how we write there is no need to calculate the value of a S2 inverse separately. From this matrix itself we able to write the S2 inverse. So, what is the S2 inverse? This become cos theta, means cos pi by 4, and this become sin pi by 4. Here this become minus sin pi by 4, sin pi by 4, cos pi by 4, and this one is a 0 0 0 0 1. This one is a S2 inverse, S2 inverse. So, this one equivalent to what? This one equivalent to 1 by root 2, 1 by root 2, 0 minus 1 by root 2, 1 by root 2, 0 0 0 1. So, this one is a S2 inverse. Now, again we perform the similarity transformation and find the matrix B2. B2 equal S2 inverse V1 S2. So, here we write a S2 inverse. S2 inverse is a 1 by root 2, 1 by root 2, 0 minus 1 by root 2, 1 by root 2, 0 0 0 1, and here we write a matrix B1. What is the matrix B1? 3 2 0 2 3 0, 3 2 0 2 3 0, and this one is a 0 0 minus 1, 0 0 minus 1 into S2, this one. So, here we write a S2, S2 is a what? 1 by root 2 minus 1 by root 2, 0 1 by root 2, 1 by root 2, 0 0 0 1. So, after multiplication of these three matrices, first we multiply this by this, then we multiply the resultant matrix with this matrix. So, after multiplication, here already we multiply these three matrices and write the resultant matrix. And what is the resultant matrix? Resultant matrix is this one, B2 equal 5 0 0 0 1 0 0 0 minus 1. So, if we examine this matrix, now this matrix now means B1 equal S1 inverse A S1 and V2 equal S2 inverse V1 S2. Now, this become, now V2 become what? V2 become diagonal matrix. Now, this become diagonal matrix, diagonal matrix, diagonal matrix, and we know that what is the eigenvalues of a diagonal matrix? The diagonal element itself with the eigenvalues. So, now eigenvalues become what? Eigenvalues become 5, 1 and minus 1. You may also write, means lambda 1 equal 5, lambda 2 equal 1 and lambda 3 equal minus 1. Now, these are the eigenvalues. Now, how we find the eigenvector? As we say in a previous lecture, how we find the eigenvector, we multiply the transformation matrix, all the transformation matrix. Here, how many number of a transformation matrix? Here we use two transformation matrix. First one is a S1 and second one is a S2. So how we find the eigenvector? In order to find eigenvector, we calculate what? S equal S1 into S2, because here we use the two transformation, S1 and S2. So if we use the three transformation, then S1 into S2 into S3, but here we use the two transformation, S1 and S2. So S equal what? S equal, first transformation is a what? S1 is a 1 by root 2, 0, minus 1 by root 2, 0, 1, 0, 1 by root 2, 0, and this one is a 1 by root 2. 1 by root 2. And what is the value of a S2? S2 is a 1 by root 2 minus 1 by root 2, 0, 1 by root 2, 1 by root 2, 0, 0, 0, 1. Once we verify this one, either we write a correct one or not. 1 by 2, this one is a S2. S2 is this one, 1 by 2 minus 1 by root 2, this one, okay. And what is S1? S1 is this one minus here, okay. So I think we write a correct value. So here we write a correct value. So after multiplication of this one, means we multiply first row by the first column, then first row by the second column, first row by the third column, second row by the first column, second column, third row by the first column, second column and third column. Then we find the matrix S, and already we perform the multiplication and write here the resultant matrix. So what is the resultant matrix? Resultant matrix is this one. 1 by 2, 1 by root 2, 1 by 2, minus 1 by 2, 1 by root 2, minus 1 by 2, minus 1 upon root 2, 0, 1 by root 2. So it's not a very tough task. You may easily able to find out a multiplication of these two matrix. So after finding the multiplication, this vector means corresponding to the first column, means if you write lambda 1 is a what? Lambda 1 is a 5, 1 and minus 1, lambda with the 5, 1 and minus 1, lambda 1 with the 5, lambda 2 with the 1 and lambda 3 with the minus 1. So what is the eigenvector? Corresponding eigenvector here, eigenvector means x1. If we denote the x1 eigenvector of a lambda 1, this one is a first column, this one is a 1 by 2, 1 by 2, 1 by root 2, 1 by 2. What is the x2? X2 is a element of a second column, minus 1 by 2, 1 by root 2 and minus 1 by 2. What is the x3? X3 equal element of a third column, minus 1 by root 2, 0, 1 by root 2. This one is a what? This one is a answer. This one is the answer. Corresponding to lambda 1, the element of a first column give the eigenvector. Corresponding to the lambda 2, corresponding to the element of a second column, eigenvector corresponding to lambda 3 equal minus 1, the element of a third column. So what is the summary of this lecture? Means how we find the solution of how we find the eigenvalues and eigenvector of a given real symmetric matrix with the help of a Jacobi method. So first of all, for a given matrix, we choose the largest off diagonal, numerically largest off diagonal elements. Then we write a transformation matrix S1 by choosing the theta in a such a way, theta equal 1 by 2 tan inverse 2 aik upon aii minus aik, where aik is the numerically largest element. Once we find the value of a theta, then we write a rotation matrix or transformation matrix S1. In place of a aik, we write a cos theta. In place of a ki, in place of a aik, we write a minus sin theta. In place of a aii, we write a cos theta. In place of a aki, we write a sin theta, and in place of a akk, we write a cos theta. In all other position of our transformation matrix, of diagonal element with a 0 and diagonal element with a 1. And after calculating the value of a theta, putting the value of a theta, we find the transformation matrix S1. Then we find a similar matrix B1 by using the relation B1 equal S1 inverse A S1. If this one is a diagonal matrix or not, examine the matrix B1. If this one is a diagonal matrix, then we stop the transformation. If this one is not a diagonal matrix, then again in a B1, we choose the numerically largest element, again find the value of a theta, again find the value of a transformation, another transformation matrix S2, again perform the similarity transformation V2 equal S2 inverse V1 S2, and examine here if the matrix is a diagonal matrix, then if matrix is a diagonal matrix, then we stop the procedure. If a matrix is not a diagonal matrix, then we repeat this procedure until we get the diagonal matrix. Once we get the diagonal matrix, then diagonal element is a what? Eigenvalues. And what is the eigenvector? We multiply the transformation matrix, all the transformation matrix. In this case, we use the two transformation matrix S1 and S2. So we multiply S1 and S2, we find the S, then what will happen? Then the first column of matrix S represent the eigenvector corresponding to the first eigenvalue, second column represent the eigenvector corresponding to the second eigenvalue, third column represent the eigenvector corresponding to the third eigenvalue. So this one is all about this lecture. I hope you enjoy this series of video lecture of numerical methods. So thank you joining the lecture. Thank you.